Ever wondered how big e-commerce platforms handle orders in real time? What if I told you you could build a mini project that simulates this using NestJS Microservices and Redis pops up all in a simple and scalable way? By the end of this video, you'll see how services like orders and products can communicate instantly without being tightly coupled. So let's jump in and make it happen. Hey guys, welcome back to Sakura Dev channel, and this is the episode 3 of our NestJS Microservices course. And in this video, we are going to implement Redis pops up for NestJS Microservices communication. Alright, let's get into it. So first things first, what is Redis? Redis, or Remote Dictionary Server, is an in-memory data store known for its speed and efficiency. It's widely used for caching, session storage, rate limiting, and message brokering. The last one enabled communication between microservices using Redis pops up. And actually, in this video, we are going to implement this in a NestJS microservices architecture. So before getting into the code, let me answer this question: why we should use Redis for microservices communication? Actually, in a microservices architecture, services needs to exchange data efficiently without being directly dependent on each other. So here, Redis helps by decoupling services. So services don't call each other directly, and this reduces the dependencies between these services. It also enables a real-time event-driven communication. In this pattern, microservices can publish and subscribe to events instead of making direct API calls. The next reason is scalability. Redis can handle thousands of messages per second with minimal latency. And last one, Redis is lightweight and fast. Because Redis is an in-memory database, it can deliver near-instant responses. Alright, with this introduction in mind, now we can move to the next part of this video where we'll set up Redis with Docker and integrate it into our NestJS microservices for real-time order processing. Let's get started. Alright guys, I open up the project that we have created in the beginning of this course. Now, in the first step, we need to run Redis on a Docker container. So you need to have Docker installed on your machine. I'm not going to go through the installation of Docker here in this video because it's really easy to install Docker on your machine. You can easily install it on Linux, Mac, or Windows. So after installing the Docker, we need to use a Docker run command to pull the Docker image and also run it in a Docker container. So in order to do that, I'm going to say Docker run command and then -- name to set the name for the image. So I just use Redis. It can be whatever we want. It's just a name that is going to be pulled from the Docker hub on our local machine. So it can be anything we want. Next, we need to use port mapping here, and I use -p here, and then I'm going to map the port 6379 on my local machine to the same port inside the Docker container. So the first one is the port inside our local machine, and the second one is the port inside the container. So we map port 6379 on our local machine to the same port inside the Redis Docker container, which is actually the default port for Redis. Okay, then we're going to use -d because we want to run the Docker container in a detached mode. It means that we're going to run it in the background. And then we need to put the official image name of the Redis inside the Docker hub. This one should be Redis. So don't confuse between this Redis here and this Redis here, which is set by the -- name. It's just the name of the image inside the Docker on our local machine. And this is the official name of the Redis image in the Docker hub. Okay, so let's run this command. So as you can see, we have an error here, and that's because we already have a image Redis on our local machine, and we need to first remove that image and then run this command again. So let me use Docker ps, which lists the containers. So as you can see, we don't have any running container. Let's use Docker ps-a, which actually lists all images on the Docker. So we have the Redis here, and let's remove that image. So I just use Docker rm Redis. Okay, now if I say Docker ps-a, you can see we don't have any Redis image on the Docker. So let's clear this up, and now let's run the first command, Docker run Redis. So here, as you can see, we have a Docker container ID, which means that the container for Redis is now running in a Docker container. So now let me use the Docker ps. You can see the Redis is running on a Docker container. All right, now let's connect to the Redis CLI inside the container. So I use docker exec command with -i and t, which actually runs an interactive terminal on the container. Then we need to put the name of the running container. It is Redis here, and then launch the Redis CLI on the container terminal. So Redis-CLI. Okay, let's run that. You can see now we are on the container terminal and Redis CLI is running on that container. So now we can use a Redis CLI and we can run Redis command like ping. So I use ping here and it actually returns pong to me, which indicates that the Redis is running properly. So now we can set a key value inside the Redis data store. So we're going to use set command here and we're going to use a key. For example, I'm going to say my key. Then we're going to use a value. So we can say something like hello Redis. Okay, let's set that and it says okay, which means that the operation was successful. So then we can retrieve that key with the get command. So use get here and then we need to put the key here, which is my key. Okay, you can see we get the value here in the next line. Okay, so that's it for running the Redis. You can see it's a data store that actually stores key value. We set the key and value, and when we want to retrieve that value, we just need to provide the key. Okay, that is actually what is the Redis does. And also you need to know that the Redis keep all those key values inside the RAM memory. So it means that it is not a permanent storage, but on the other hand, it is a very high performance data store. So that's it for running the Redis on the container. And now we can move to our NestJS microservices and configure Redis for inter-service communication. All right, so before moving to the NestJS microservices, let me show you the scenario that we are going to implement. Okay, so here the microservices application that we have created in the previous episodes, we have the API gateway and we have all these microservices here. And as you can see, we have set up the TCP communication transport between all those microservices and the API gateway. So now here's the scenario. In the API gateway, we have a HTTP endpoint for creating an order. Then the API gateway forward this request to the order service. It means that it sends a message through TCP channel to the order service. We have seen how we can do that in the first episode of this course. Now here in the order service, we want to send a synchronous message to the product service for handling the inventory of the product. It should be asynchronous, and we want to do that with Redis. So after order is created, the product service must actually update the inventory. So as I said, from the order service, we are going to emit a order created message through the Redis channel, and product service must subscribe to the Redis channel and listen for order created messages and then get that message from the Redis channel and handle it inside it. So our architecture should be like this. So here from the order service, we are going to send a message to the product service through Redis channel. So our architecture would be something like this. The product service is connected through the TCP2 API gateway, and in the same way, it's subscribed to the Redis channel and listen for order created message from the order service. So now let's get to our project and implement this architecture. Okay, so get back to VS Code and let me close the terminal. And then I go to the product service. So let me find the product service here and go to the SRC. And here in the main.ts file, you can see we already have configured this microservice to listen to the TCP transport layer. Now we also need to make it listen to Redis channel. So here, let me rename this app here to TCP microservice. So TCP microservice. So it, as before, will listen to the TCP transport layer. Okay, let me just comment out this app that will listen. And then here, let's create another microservice that will listen on the Redis channel. So here, I'm going to say const Redis microservice and set it to await nest factory dot create microservice. Put the microservice option here. Okay, and in the parameter of the create microservice function, put our root module, which is the app module. Okay, and in the second parameter, we need to put the config object and we need to set the transport to the transport.redis. Okay, then we need to set the options, and inside the options, we're going to set the host to localhost because Redis container is running on a local machine. And then we need to set the port. We're going to set it to port 6379 because we map this port on a local machine to the same port inside the Redis container. Okay, now here we're going to use await promise.all, and then inside it we're going to say TCP microservice.listen, okay, and also Redis microservice.listen. So in this way, we created a microservice application that listens on two different channels, on TCP and Redis. Of course, we can configure it to just listen on one of these ports, Redis or TCP. Okay, I just wanted to show you we can have multiple listening channels on a microservice. So now let me get back to the diagram here. In the API gateway, we call the order service through the TCP channel, and then inside the order service, we need to emit a message through Redis channel to the product service. So now let me show you this scenario in the application. Let me go to the API gateway and open up the orders controller. In the API gateway, you can see we have a host endpoint here, which is for creating an order. And then it sends the create order message to the order service client that we have injected here in the constructor. If I go to the app module here, we can see we have registered the order service in the client module. So you can see we say that we create a client, we register the order service and specify the transport channel and its port. So if I go to the orders microservice and open up the main.ts file inside the order microservice, you can see the application here is configured on the TCP channel and on port 401. So get back to the app module inside the API gateway. You can see we have registered this client with the same port on the TCP channel. So we can send messages to this client. Now, if I go to the orders controller inside the API gateway, we inject that order service inside the constructor and then send the message to that order service. I suppose that you have watched the first and second episode of this course, so I just don't focus on TCP and how to configure microservice to listen on TCP channel. Okay, so now let's get back to the order service and open up the order controller inside that microservice. You can see here we have a message pattern, create order, and we have a corresponding function here, and we just return order created. Now in this function, we want to emit a order create event, and then on the product service, we want to subscribe to that event, get that event, and process this event inside the product microservice. Okay, now let me go to the product microservice, and here in the product controller, we have already a message pattern which actually works with the TCP get product. With this message pattern, the API gateway can get the product details. Now we want to create an event pattern named order created, and actually this event pattern will listen to order created events through the Redis channel. So here I'm going to use @event pattern. Okay, now we're going to put a name for the event. I'm going to say order.created. Okay, then we want to create a function for this event. I'm going to say async update stock. Okay, and we need to get the order here. So order, we can use DTOs and validation just like a normal NestJS application. I have an episode in our previous course, NestJS Full Course. You can go to the data validation episode of that course to see how we can do that. But for now, let me just keep it simple. Let's set a type for the order. It is going to have an ID inside it, which is going to be a number, and also the product ID, which is going to be number as well. Okay, now here in the function, we're going to log a message console.log and say something like checking stock for the product and put the order.product ID. And then here we can log another message, say something like stock updated. All right. So here, as you can see, we do not return anything, which means that it is going to be a asynchronous communication. We don't want to respond anything back to the client that emits this event. Okay. Now let's get back to the order service and emit this event. Okay. So I go to the order service, and first we need to register a client for the product service. So I go to the app module here, and in the import section, I'm going to use client module that register, and we can register the client for each microservice that we are going to use in this microservice. So we need to put an object here. First, we need to set the name. We can set it as product Redis service. So as I said in the first episode, since we need to use this name when we want to inject this client into other controller and services in this microservice, let's put it inside a constant. So here I'm going to create a constant.ts file here and export a constant named microservices, and it's going to be an object. And inside it, I'm going to say product Redis client, and we're going to set it to just the same name that we have here. So just copy that and paste it here. Okay, let's save this, and here, instead of hard coding this, let me just use the microservices dot product Redis client. Okay, now we need to specify the transport layer. It is going to be transport.redis, and I'm going to set the options here, set the host to just localhost. If it's on another machine, we need to provide the ID of the machine that the Redis is running on. Next, we need to specify the port, which is going to be 6379. Okay, now we can inject this microservice client in the order controllers here. So first we need to put a constructor here, and in the constructor we need to use @inject and provide the name of the microservice. So use microservices constant and product Redis client. Okay, then we just can have private product Redis client and set its type to the client proxy. Okay, now here, before returning the message to the user, we can just use this .product Redis client .emit. So here, we're going to use the same event pattern that we have used in the product controller here. So it is order.created. Let me get back to the order controller inside the order service and put the same key here. Then we need to put the order inside the body of the message. Okay, so as you can see, this is not a synchronous blocking connection. It just emit that went, and immediately after that, it runs this command and returns this message back to the service that sends this message. Okay, it's the API gateway. All right, so let's save this, and now let's open up the terminal. Let me just open another terminal here, and let's run the monorepo. So before doing that, let me just go back to the product service, and in the main file here, let me change the product service here, which says that product microservice is running in port 402 and listen to Redis events. Okay, let me save this, get back here to the terminal, and now let's run the monorepo and all project inside it, npm run start dev. Okay. So here in the product service, we have an error which says that the Redis package is missing. So let me just turn off the dev server here, and let me clear this off, and let's run the npm Redis and install the Redis package, which is required if we want to use Redis in our NestJS applications. So let's install that. Okay, it is installed, and now we can run the microservices. So the user microservice is running on port 403. The order service is running on port 401. This is the API gateway, and this is the product service, which is running on port 402 and also listen to Redis event. So as I said, this product microservice listening on two channels, normal TCP, which is on port 402, and also listen to the Redis channel. Now let me just open up the Insomnia. Okay, so here, let me clear this history. Now let me just send a request to the localhost 3000, which is the address of our API gateway. And let me put a product ID here and say something like 12. Okay, and then send this request to the API gateway. So as you can see here, we've got the order created, and let me get back to the application here. So first, let me go to the order service. You can see the message here, order received on the order microservice, and this is the order product ID 12 and name order 1. Now let me go to the product service. You can see the message here, checking stock for product 12 and stock updated. So this means that our Redis channel is working without any error. So let me explain it on the diagram here. First, we call the /orders of the API gateway. It sends a message through the TCP to the order service. Let me show you in the API gateway. Go to the orders controller. Let me close the terminal. You can see we have the post endpoint here, and we send the create order message to the order service client. Then in the order service, we catch the message. So let me show you in the orders microservice. You can see we have a message pattern, create order. We catch that message and log order received on the order microservice and put the order here. Let me open up the terminal and see the order service. You can see the message here and the order object. All right, let me close this off. Now, here in the order service, we emit a asynchronous event to the Redis channel, this is this line using the emit with order created message here. Okay, now in the product microservice, we have an event pattern here with the same key order.created. We've got the order here, and first we log checking the stock for the product, and then finally we say stock updated. Okay, so let me open up the terminal. You can go to the product service. You can see this message here, checking stock for the product 12 and stock updated. So in this way, we can implement asynchronous communication between the order service and product service. Yes, that easy with NestJS. Okay, before ending this video, I'm going to tell you that with the Redis channel, we can also have synchronous communication between these two microservices. So now let me get back to the VS Code. Let me get back to the product microservice. You can see here, we have a message pattern get product. Okay, with Redis channel, we can also send a synchronous message to this endpoint. So let me get back to the orders controller here in the order service, and here instead of returning this message order created here, we can just return and then use the product Redis client, and instead of emit, we can just use send, which is for sending a synchronous request to the product microservice. And then we need to use the same message pattern here, get product. So let me just copy that, get back here, paste it here, and in the second parameter we can put the data. We don't have any data, so we can just put a empty object here. So here, instead of returning this message order created to the API gateway, we just return this object. Okay, so now let me get back to the Insomnia, and this is the response from the previous call to the orders of the API gateway. Now let's send the request again. You can see this time we return the object that we have returned in the get product message pattern. So in the same time, we can use the Redis channel for synchronous and also asynchronous communication. So use the emit for sending a asynchronous request to the client, and use the send method for sending a synchronous message to the product client. Let me open up the terminal here. You can see both of these two messages. The stock updated is also on the terminal, which means that both emit function and send function is working. All right. As the last thing I'm going to show you here, let me get back to the terminal, which are running the Redis CLI inside the Redis container, and use monitor command here. Now let me send the request here. Okay, let me get back here. You can see the messages that is delivered through the Redis channel. First, we publish an order.created event with this pattern order created and this data, which is an object that has product ID and name inside it. Then we subscribe to the get product.reply, which means that this is a synchronous request. We subscribe to the reply of the get product endpoint. And actually, in other words, it means that we wait for the reply of this get product endpoint, and then we publish this get product message, and here we publish the reply, which is a response, which is the ID, name, and price from the get product endpoint in the product service. And finally, unsubscribe from the get product.reply. So through the Redis channel, we have created a synchronous communication in these 3 steps. So yeah, that's it for this video. We have used the Redis pops up channel for sending asynchronous events and also synchronous requests to the product microservice. I hope this makes sense to you. And if you have any question about this, leave it in the comment section below. All right, before ending this video, let me do a quick recap on the diagram. In the product service, we have created 2 microservices. The first one listing on the TCP and the second one listing on the Redis channel. Then in the order service, we have created a client for the product service and configured the transport to the Redis channel. And with the client.emit, we emit asynchronous messages to the product service. And with the client.send, we send synchronous messages to the product service. With the asynchronous events, we do not return a reply to the order service, but with the synchronous messages, we need to return a reply to the order service. All right, that's it for this video. And if this video was helpful for you, please hit the like button and also subscribe to the channel for the next episode of this course. Have a nice time. Bye-bye.